Hello and welcome to another lesson of GCSE Physics. Today is the first lesson on the topic of electricity and the learning intention is to know what an electric current is. For the Do It Now task, I would like you to answer two questions. What do you think each of the symbols below mean, and why are symbols often used instead of words for various different reasons and uses? Pause the video, write down your answers and then press play to check your work. So that first sign that we have there with the 30 in the red circle, of course, means that we have got a maximum speed of 30 miles per hour. The second one, the one in the middle, you will have actually seen before on GCSE Physics. That symbol is used to indicate that something, a substance or a material, is radioactive. And then finally, the one on the right-hand side is one that you're going to encounter when you move on to A-level physics. That is one that suggests that there is a laser in use. Now, symbols, these are just three, but there are lots and lots of symbols used across all of science, and to be perfectly honest with you, all throughout life. We normally use symbols because they have a universal meaning, meaning that no matter where you are, they all mean the same thing regardless of any language barriers that may exist. So, the success criteria for this video lesson today is to know what ammeters and voltmeters are used for, to know how to wire up an ammeter and voltmeter correctly, and to know the circuit symbols for a whole host of different components. Now, the first thing we're going to do is look at 14 different circuit symbols that we need to learn, and we're going to look at what each of them do. So, the first one is the circuit symbol for an ammeter. That is something that you might have come across at Key Stage 3. And as you can see, the circuit symbol for an ammeter is a circle with a capital A inside. It does need to be a capital. It is not correct to draw it with a lowercase a. Now, ammeters are used to measure the size of an electric current. They need to be connected in series with a circuit to be able to work properly. The second symbol on the board at the moment is for a voltmeter. Now, voltmeters are used to measure the size of a potential difference. Potential difference we will do more about next lesson, but for now you can think of it as another word for voltage. Voltmeters need to be connected in parallel to be able to work properly. Here we've got two different versions of the same thing. These both represent switches, but switches in different positions. Switches enable the current in a circuit to be turned on or off. Now, the first one would show us an open switch. When a switch is open, there is no current flowing because we haven't got a complete circuit. The second one, the bottom one, shows a closed switch, and that means that a current can flow because the circuit is complete. Here we've got more circuit symbols. We've got the symbols for cells and batteries. Cells are needed to push electrons around a complete circuit, which is what causes a current to flow. And a battery consists of two or more cells. The first symbol is for a cell, the second one for a battery. You might notice as well that there is a plus next to the larger of the two lines that are in the symbol for a cell. That indicates that the longest arm is the positive terminal. You might see this drawn without the plus next to it, and you would need to know that the longer arm represents the positive end of the cell or the battery. Okay, now we move on to a fixed resistor. A fixed resistor is very simple to draw. It is just a rectangle with obviously two wires coming off it from either side. A fixed resistor is used to limit the current in a circuit. The bigger the resistor, the less current can pass through it. We'll do more about resistance later on in today's lesson. Then we can have something called a variable resistor. We would draw the symbol for a variable resistor in the exact same way that we have drawn the symbol for the fixed resistor. However, we would also draw an arrow going through it at a diagonal, as I've done for you there. Now, a variable resistor allows the current in a circuit to be varied or changed. The higher the resistance is set to on the variable resistor, the smaller the current will be. Okay, now we've got a diode. A diode is drawn as shown there. We would start off with a circle and a line going all the way through it, representing a wire. Some students actually, when they see this, reference the fact it kind of looks like a play button because we've got a equilateral triangle drawn there on its side with a line at the tip of the right-hand side edge. Make sure that when you're drawing your circuit symbol for a diode, you don't have that triangle or the line inside it touching the circle. There does need to be that space in between them, and examiners will penalise you if your circle is touching the triangle on the inside. Now, the purpose of a diode is to only allow the current to flow in one direction through a circuit. This means that they can be used as rectifiers to convert an alternating current into a direct current. Then we've got the circuit symbol for a light emitting diode. A light emitting diode is drawn exactly the same as a regular diode, but we have two lines drawn going away from it on the right hand side of the diode. That is representing the fact that light is being given off. An LED will emit light whenever a current passes through it. Like a normal diode, it also only allows current to flow in one direction. Now we have the circuit symbol for a lamp. Lamps emit light when a current passes through them. You can essentially think of a lamp as being a bulb. They are used in all sorts of situations, such as car indicators, household lights, etc. Now we have the circuit symbol for a fuse. A fuse again is drawn like a normal resistor, but the line representing the wire carries all the way through it this time. A fuse is designed to melt and therefore break the circuit if the current becomes too big in the circuit. This is important because if the current does get too large, then that can damage the components of the circuit, and in worse scenarios it can actually lead to an electrical fire. Tin is the material that is most commonly used in a fuse because it has a melting point at the right temperature for use. You might sometimes find now though that not all houses have fuses as part of their circuits, because sometimes circuit breakers or residual current circuit breakers are used in place of fuses because they can act that little bit faster, but still lots and lots of appliances do make use of their own fuses. Here on the left hand side we have an LDR. LDR stands for a light dependent resistor. You will begin this by drawing a normal resistor and then drawing a circle around it and two arrows going towards that circle on the left hand side. This is drawn as so to represent light hitting the resistor. The resistance of the light dependent resistor depends on the amount of light that falls onto its surface. In bright light, the resistance of the LDR is going to be low. However, in the dark, it has a very high resistance. Then the last one that we're going to look at for today is a thermistor. A thermistor we would draw just like you would draw a normal resistor, a normal fixed resistor, but then we are drawing two lines. One of them is going through to a diagonal like the arrow did previously, and then that is met by a horizontal line at the bottom. Make sure that you do not draw that as an arrow though, because that would be incorrect. The resistance of a thermistor depends on the temperature of the surroundings. When very hot, the resistance of the thermistor is low. The colder it is, the higher the resistance would be. So, now we're going to talk about what current actually is then. We've looked at all these different circuit symbols and lots of them are to do with current, and I'm going to use the idea of a torch to explain to you how a current flows and what a current actually is. So, an electric current is a flow of charge. When the torch is on, millions of electrons pass through the torch bulb and through the cell every second. Each electron carries with it a negative charge. Metals contain lots of electrons that move about freely between the positively charged metal ions. These electrons stop the ions moving away from each other. The electrons pass through the bulb because its filament is made of metal. The electrons transfer energy from the cell to the torch bulb. That's why torch bulbs get hot. The size of an electric current is the rate of flow of charge. This is the flow of charge per second, and the greater the number of electrons that pass through a component, the bigger the current passing through it will be. So, we said when we were looking at the symbols that current is measured using an ammeter, and of course potential difference or voltage is measured using a voltmeter. Now if you were in school, rather than watching this as a video, you would probably get the opportunity to wire a voltmeter and ammeter up into an electrical circuit, but here I've just included a picture so that you can see what those two components look like in real life. Now, we said as well that an ammeter has to be connected in series. What that means is that the ammeter has to be part of the main loop of the circuit. Now if I just get the highlighter out to make my point here about what this means, I've got the laser pointer there. When current flows around this circuit, it has to flow through the ammeter, which it will do there because it is part of the main loop. You will notice instead that the voltmeter is not part of the main loop. The voltmeter has this own branch of its own. Now that's important because for it to work properly, a voltmeter needs to be connected in parallel. So, what actually causes resistance then? We've said that current is caused by electrons moving. Of course, electrons carry negative charge. But what actually is resistance then? On the board, I'm showing you the diagram now of what a metal looks like, or what a metal wire would look like on a very, very small scale. You would see electrons would move through the metal wire, and those large orange things are the positive metal ions that make up the bulk of the metal. The electrons are pushed around a circuit by a battery or a cell. As the electrons move through a metal, whether it be a resistor or a bulb, etc., they will of course collide with the metal ions. When the electrons collide with the metal ions, they transfer energy to the ions, which makes the ions vibrate more. The increased vibrations of the ions make it harder for the electrons to move through the wire, and that is what the cause of resistance is. Now, there is an equation that links these three quantities that we've learned about today, and the equation is that potential difference is equal to current multiplied by resistance. In symbols, that can be written as V for potential difference, I for current, and R for resistance. Potential difference is measured in volts, current is measured in amps, and resistance is measured in ohms, which is that symbol omega that I've got at the bottom of the board for you. Now, that actually leads us to something known as Ohm's law. Ohm's law tells us that the current is directly proportional to the potential difference. When two things are directly proportional to each other and we draw a graph, you would see that it will be a straight line that goes through the origin. Now, any component that obeys Ohm's law, when you draw a graph of voltage against current, you will see that it does give you a straight line going through the origin, as the one does there that I've included on the board. Now, I want to have a go at doing some calculation questions. This is an activity that we would typically have done on whiteboards in class. You can pause the video for each question, have a go. You will need a calculator, of course, to do this, and then we will go over the answers as well. So for the first question, calculate the reading on the voltmeter in this circuit. Pause the video and then press play to check your answer. So to do this then, we will be using the equation we just looked at, which is potential difference equals current times resistance. Now the current is 1, because current is measured in amps, of course, and the resistance is 10, because that is 10 ohms. 1 multiplied by 10 gives us an answer of 10 volts. Okay, the second question for you to have a go at, work out for me please the value of the resistor. So we're going to be using the exact same equation. We're still using potential difference equals current times resistance, but this time I have an issue. The equation is not written as resistance equals, so I need to change this equation around. You will remember, of course, when we've done other equations, the way we change an equation around is by drawing an equation triangle. Now, the equation triangle would have potential difference on the top and current and resistance on the bottom. So to write the equation as resistance equals, you would obviously cover that up with your thumb and look at what you've got left, and you have potential difference on top of current. So therefore resistance is potential difference divided by current. So I would do 5 divided by 3, which gives a correct answer of 1.67 ohms. Please don't forget to include that symbol for ohms at the end of your answer. Okay, what is the voltage across a 5 ohm resistor if the current flowing through it is 1 amp? So again, we're going to use potential difference equals current times resistance. So we do 5 multiplied by 1, which gives us a correct answer of 5 volts. Question number 4, if the voltage across a 30 ohm resistor is 3 volts, what is the current? So to work this one out, again we're using the same equation, we're always using this one today. You would need to draw a triangle. Now, when you cover current up to find out how potential and PD and resistance are related, you've got PD on top of resistance, so you do potential difference divided by resistance. That means you would do 3 divided by 30, which gives you the correct answer of 0.1 amps. Okay, this time it's a little bit more to it. You will notice that the potential difference has been given in kilovolts. You need to remember that kilovolts you would need to times by 1,000 to get into volts. The only unit that we actually work in kilo of anything is kilograms for mass. So you would get a mark for saying that 5 kilovolts equals 5,000 volts. I would write that down specifically as part of your working out to make sure that you get a mark even if you make a mistake later on in your working out. We then write down the equation as always and draw the equation triangle, and we do 5,000 divided by 2, which gives us 2,500 ohms as our answer. Okay, and then the last question for today, if the voltage across a 5 ohm resistor is 0.1 volt, what is the current passing through it? So again, no guesses for which equation we're using. It's PD equals current times resistance. We would draw our equation triangle for it with PD on the top, and then current is going to be 0.1 divided by 5, which gives us an answer of 0.02 amps.